Hi, welcome to our pre-calculus. Topic today is composition of a trigonometric function with the inverse of another trigonometric function, problem type 2. You see that I have drawn some pictures so that we save a bit of time. I'm going to come and explain how we are going to make use of all these pictures and the formulas here. So let's take a look at what we are facing. So it's asking what is the cotangent of, so here's the one function, cotangent of, inverse of another function, cosine inverse of, then, well, some number. So we have one trigonometric function and the inverse of another trigonometric function. In the previous lecture, they were both same function and its own inverse. Now we are mixing them, and as a result we have a lot more possibilities of this type of problem. So let's just go ahead and see step by step what is meant by cosine inverse of some number. Best thing is to have a visual impression, and if you have that, answering the question is going to be easy. It's possible to answer these things by formulas, but then you are going to require, I think, about 15 different formulas to work it out. So might be a good interesting exercise for students who want to give themselves an additional challenge, but I would say going by pictures is best. Okay, cosine inverse. Cosine inverse is this circle here. Okay, remember cosine inverse, we were supposed to give an angle that is between 0 and pi. So everybody remembers that? So we were supposed to create an output between 0 and pi. So 0 is here, pi is over there. Cosine inverse of minus 2/3. Minus 2/3. You remember cosine matches with x. So wherever minus 2/3 is, that is where our angle is projecting. So let's go redraw this thing and practice all over again here. So I draw the unit circle. So here's a nice unit circle, and then here is, let's say, the x-axis that we have. This is our x-axis. Here's my origin. Where is minus 2/3? First of all, we remember that cosine matches with x, so that minus 2/3 somewhere on the x-axis. And then the angle is such that when we project it, we come down here. Well, you could have started from this location and come down, and you could have started from this location and come down. And then we said with respect to cosine, we are looking at this range of angles up here between 0 and pi. So we are not going down here, so this section of the picture is out of the picture, so we shouldn't have that. We just have the upper half. Now what's the angle that we are interested in? This is what we are talking about. So up to here we understood what we are this is cosine inverse of minus 2/3. Okay, great. So what is it that we want? Whatever this angle is, we want to find its cotangent. We want to find its cotangent. Now this is the unit circle. Unit circle, the radius is always 1. To standardize everything, we use that. Now, from experience, I know that students get in a bit of a hard time with handling fractions. You have to square them, subtract them, take a square root, and so on. And chances that something's going to be missed is quite high. So what I strongly recommend, trying to get rid of this denominator. Well, how do you get rid of it? You can just throw it away. We are going to take our picture and blow it up. Blow it up by what? By just this denominator. That means I'm going to take a look at the following picture. So something similar to that. It's just that when I multiply everything by 3, this becomes minus 2, this becomes 3, but angles all stay the same. Okay, angles all the same. So what, now we go to the next one. What was cotangent? Cotangent is ratio of x to y. So here's my x. What is my y? Y, well, we apply Pythagorean theorem. This is, I say, square of this one, 3 squared, square of the other one. Oh, the minus always disappears, so you might as well just write 2. When you square and subtract them, you get 9 minus 4, and that is 5. Make sure you don't make a mistake on this negative. Negative, when it squares, it becomes positive. Or just think about 3 squared minus 2 squared, that's 5. So what is cotangent of this angle? Cotangent of our angle is a ratio of what? X to y. Is that right? Cotangent is a ratio of x to y. No, well, that's all there we needed. My x is minus 2, my y is radical 5, and there comes the answer, minus 2 over radical 5. Okay, so let's repeat again. Minus 2/3. Cosine is matched with the x-axis. We go on the x-axis, figure out where minus 2/3 is. Now, where was the angle? We could go up or down. Cosine inverse is up only. We go up to this location. So this is the radius 1, and our angle here is what we are after, cosine inverse of minus 2/3. That's our angle theta. What is it that we want? We want the cotangent of it. Cotangent is a ratio of x to y. I could go here and try to find ratio of this x to this y. That would be perfectly fine and correct, except that in addition to all the other things, we have to deal with fractions as well. So I recommend the following. Take this picture and blow it up by your denominator. So denominator was 3. When I blow up this minus 2/3, it just becomes minus 2. Radius was 1, now it becomes 3. The other side, y, now I calculated. The advantage is that I don't have any fractions to worry about. So it becomes radical 5. I still need to know cotangent is x to y, and that gives me the answer. Let's go try another one. Cosine of sine inverse of minus 5/6. So some number is given. And then we apply inverse trig function to it. So that's my inverse trig function. Outside comes another trig function. So a trigonometric function and inverse of another trigonometric function. So that's what we are referring to. These are two different ones. Previous lecture had both of them. Now again, you can do by formulas and such, but I just don't recommend it to get a feeling for what we are talking about. Well, how do I eyeball this? How do I get a feel for what is sine inverse of minus 5/6? Again, we go ahead and draw a unit circle. Okay, now hopefully we remember that sine is read on the vertical. Is that right? Sine is read on the vertical. So this is our sine axis here. If I have a number and I want to find the sine inverse of it, I just go horizontally until I hit the circle. Hit the circle and then connect to the origin. If the number is given positive, I go up. If the number is negative, I go down. So let's see, what does it mean here. Here we have my number is minus 5/6. It has to be drawn on the vertical. Okay, sine goes with the vertical. Minus 5/6. Try to eyeball it and give some reasonable number. This is minus 5/6. Minus means go down. So minus means go down. Then what? Then go horizontally. Well, horizontally I can go to right, horizontally I can go to left, but last couple of times we made a big fuss about well, we are just choosing this side only, and the other one we are just clipping it off so that we have only one answer. Okay, so far so good. So what angle are we talking about? The angle we are talking about is this angle. This is sine inverse of minus 5, 6. All right, so if we were on a deserted island, we have nothing better than this to do. We can actually draw this thing on sand and have a feel, okay, this is sine inverse of minus 5, 6. You can actually look at it as opposed to having a dependence on a calculator all the time. So sine inverse of minus 5, 6 is that angle. Okay, now great. What is it that I want? I want the cosine of this. So this is angle theta. I want cosine of this. So how do you draw a cosine? Okay, if you have some angle to draw the cosine, you come straight down to the x-axis, and then this line, this is what the cosine is going to be. This cosine comes from that. So here I now need to go, this is the cosine axis. I go to the cosine axis, and now the fight is over the following. What is this? What's the length of that? Okay, let's redraw everything so that we are not lost in that circle. So I draw. What is it that I know? I know this side is minus 5, 6. I know the radius of the unit circle is 1. What I'm missing is this x. Okay, we can go and apply Pythagorean theorem to find x, but instead I suggest you blow things up. Now I don't have room here to blow something up. Let's imagine I blowed it up. So I'll draw the following. Blow up by what? Blow it up by a factor of 6. So this is a whole number. It was 1, now it's 6. This was minus 5, 6. It becomes minus 5. Now I'm asking, what is this one? Well, very easy. You say square root of 6 squared minus 5 squared. So 36 minus 25 is 11. Is that right? 36 minus 25 is 11. What is cosine? Cosine is the ratio of adjacent by hypotenuse. They're both positive, so I get the square root of 11 by 6. You got that? So let's do another one. Secant of sine inverse of minus 4/7. So let's be quick on this one. So we have let me try this thing again. Okay, that's good enough. Minus 4/7. So where does that go? So again, this is the sine axis. This is the sine axis, sine matched with y. Minus 4/7. 4/7. So somewhere here. Minus 4/7. Okay, minus 4/7 on the vertical. Then we go horizontally just to the right. Connect to the origin. That's the angle we are talking about. In this triangle, now I make a triangle. So this side of it is minus 4/7. This side of it is 1. And that's it. Now I take this picture and blow it up by a factor of 7. Now, it have to be bigger than that, but that's fine. When it becomes bigger by a factor of 7, what does that do? This side becomes -4, this side becomes 7, and I need the other one. Now, advantage is that I don't fight with the fractions. Fractions are gone. So 7 squared minus -4 squared, 49 minus 16. So what is that? 33. Now, what is secant? Secant is the ratio of hypotenuse to the adjacent. And the adjacent is radical 33, is positive. So it's going to be radical 7 hypotenuse over adjacent. That's it. Let's try another one. Let's see how many of these we have. Yeah, one more. Cosine of tangent inverse of -3. So one more time, we go ahead, and here is my tangent. Well, I have to draw it. Let's see. So here's your cosine axis. Here is your sine axis. But what we care for is the tangent axis. Tangent axis is here. Okay. Tangent of something turned out to be -3. Well, can you show me that? Well, I should have drawn my circle a bit smaller, but forgive my incorrect size. So suppose this is -1. I need to go -2 and -3 is all going to be all the way down here. But suppose, for the sake of discussion, this is -3. So remember, this is the radius of the circle is 1. So -3, to be a little bit lower down, but say that is -3. What is tangent inverse of -3? We said what you do is that you connect from the origin to this location. This is theta. Theta is equal to tangent inverse of -3. Why not other choices? Let's go back up here. You connect to the origin, or here. If this is t, tangent inverse of t is this angle and has to be chosen in the range from -pi/2 to pi/2. We stay in the yellow region. So okay, now what do we want? We want cosine. In this picture, all of my numbers are whole numbers. I don't need to blow anything up. This is 1, this is -3. So my radius becomes 1 squared plus -3 squared. That's radical 10. Well, what's cosine of theta? Cosine is going to be adjacent over the hypotenuse, and I get 1 over radical 10. Okay, cosine of angle of theta is 1. Here's 1 is my adjacent. Here is my hypotenuse. We are just using a visual version of what we had here. Cosine was x over r. Whatever x is divided by whatever r is, that's going to give us our cosine, and that is what I did, and just call it adjacent over hypotenuse. Similar setup, tangent inverse of -8. So we just learned the picture that we had, -8. This is 1, this is -8. This is the angle. So this is x, this is y. R becomes sum of square root of these two becomes 65. 8 squared and 1 squared makes 65. So what is sine of theta? Sine is y over r. Y over r is minus 8 over radical 65. So this becomes 8 over radical minus 8 over radical 65. So it all of these problems says give exact value. Don't use any calculator. Okay, so these are more exercises on getting our bearing with respect to which quadrant we are in and how these functions work with each other. The only place you are going to see this thing is in calculus 2. You are going to see some applications of these things over there, and also in some perhaps physics classes. So until then, good luck and God bless.